All right, so this is 1-3A. We're going to do 1-3B tomorrow. We're starting with angles. This is angle measure. And I want y'all to take notes on paper. Nice vocabulary. Most of this is vocabulary, and then I'm going to go through a couple examples. And then you're going to have an online assignment in the online textbook, 1-3A.
Can I see these online right now? Yeah. Okay. How do I get there?
Go to my It's Learning, and then click on the link to my OneNote. Okay, so array. So whatever I underline is what you should write down. If you want me to tell you what to write. Array is part of a line having only one endpoint. Part of a line, one endpoint. So for an example of array, it would look something like this, with some points on it. So that's array CD. And when I name array, so remember if I had a line segment CD, the order of the letters didn't matter. I would just pick two endpoints and put a dashed line above it. For a segment, it doesn't matter. For array, it does matter because there's only one endpoint, and in the other direction, they go on forever. So where the arrow is, it's going on forever in that direction. So this would be array CD, and the arrows always point to the right when we're talking about array. And I did it this way on purpose that my example of the array is pointing to the left, but my symbol with the letters CD is pointing to the right. The symbol always points to the right. But the order of the letters matters. Because if you see here in the example, the end point is where C is. So the end point is where C is. The D is closer to the arrow. So the D is closer to the arrow. The symbol always points to the right, and you put the letters to match the picture. All right? That is array. An angle is a figure formed by two rays with a common endpoint. Two rays with a common endpoint is an angle. So if we have this, I'm going to call this A, B, C. We have two rays. I have ray BA and I have ray BC. They have a common endpoint B, and that makes an angle between them. I could name this angle as angle ABC, or I could name it as angle CBA, or I could just name it angle B. The order where the B is, in this case, is important. If you notice the common endpoint, B, when I use three letters, it's in the middle. That common endpoint has a special name, which is the next vocabulary. It's the vertex of the angle. In this case, that's vertex B. It's where the two lines meet, the common endpoint. So when I named it, I put the vertex B in the middle, or the B in the middle, or I can use just the vertex to name it. So all three of these are okay ways to name that angle. And the vertex is the common endpoint of the angle. So an example, okay, right there, that's the vertex. All right, these next two vocabulary terms should be pretty obvious. I think you know what they are. Interior of the angle. Inside, the space inside the angle. Space inside the angle. So if I have this angle, all of this space inside the angle is the interior. Everybody agree with that? We're good? So then the exterior of the angle is all the space on the outside of the angle. Space outside the angle. So again, if I draw the same angle, the space outside is everywhere out here. Anything outside is the exterior. Eventually, we're not going to have all this vocabulary, but this unit 1, is basics of geometry, so it makes sense we have to start with the lingo, the vocabulary you need for this class. Degree measure of an angle is a unit of angle measurement. The degree is the unit of measure. There's two ways to measure an angle. There's degrees and there's radians. We're not going to use radians. In pre-cal, they use radians when talking about the unit circle. There's a bunch of square root symbols in there. We're not doing it that way. We're going to use degrees. That's not degrees like temperature degrees. It's degrees like a circle is 360 degrees, right? I'm not even going to mess with an example for that. An acute angle, you probably already know this. It's the cute little angle, the little one. So that would be an acute angle. I'm going to call this one 20 degrees. It's an angle that is between 0 and 90 degrees. 0 degrees and 90 degrees. So if you have an angle that's 0 degrees, you don't have an angle, right? Because that's nothing. It's just a line. If you have an angle that's 90 degrees, well, that's a special angle. It's right here. That's a right angle. So anything in between there, tiniest bit greater than 0 or the tiniest bit less than 90, and it's acute. A right angle is an angle that is exactly 90 degrees. It can't be off even by like 1/10 of a degree. It has to be exactly 90 degrees. And it makes a corner. And there's a reason I use the word corner, and we'll get to that later, probably tomorrow. 90 degrees. It's a right angle, it makes a corner. And we put a little box inside, and that means 90 degrees. An obtuse angle, that's the big angle. It's an angle that is greater than 90, but it has to also be less than 180. So it's between 90 degrees and 180 degrees. So it looks something like that. That could be an obtuse angle. And say it's 130 degrees. I don't know. That's an example. Because remember, 90 degrees, that's a right angle. If it's 180 degrees, that's a straight angle because it makes a straight line. Is exactly 180 degrees. No more, no less. And then, not that you need it for this class, but anything greater than between 180 and 360 degrees would be a reflex angle, bigger than 180. But we don't deal with those. That's just your little trivia to impress your friends. Congruent angles. We defined congruent yesterday. Remember, it was that symbol, equal sign with a squiggle on top? A tilde. That's the squiggle's name, a tilde. an equal sign with a tilde on top. Two angles that have the same measure. So if they have exactly the same measure, it doesn't matter which direction they're facing. So if I have this angle, if that's 20 degrees, and I have this angle, and that's 20 degrees, those are congruent angles. It doesn't matter if they're facing the same way or not. They're still as long as they're the same size, then they're congruent. Because their measure is the same. All right, angle bisector. So first I want to look at the word bisect. If we have a bisector, that means to cut exactly in half. When I say cut in half, I don't mean like close to in half. Cut exactly in half. That's what that means. To bisect is to cut in half. So yesterday we had midpoint, and midpoint was exactly halfway. And so we could say the two sides equaled each other because they were exactly halfway. So that midpoint is a bisector of a line. Here we have an angle bisector. So an angle bisector is a ray that divides an angle into two congruent angles. So, for example, if I have this angle A, B, C, and there's a ray BD, if ray BD is an angle bisector, then it will cut angle ABC exactly in half, and I'll mark it in my diagram like that with a single line or two lines. It doesn't matter how many lines, as long as it's the same number of lines. So if one of them had one line and the other had two lines, that means they're not the same. But if they both have one line, that means they are the same. So if you see the word bisector, you want to label your picture to match. The same as we did yesterday, is that if you see the word midpoint, mark the segment to show that the two sides are the same length. So we're marking it congruent with the word bisector. Last word or definition or term is a postulate, the angle addition postulate. And this is almost exactly the same as yesterday with the segment addition postulate. Now we have the angle addition postulate. Means the same thing, but we're talking about angles. When I abbreviate this, I will call it the AAP. When we get to proofs, I will be just abbreviating because there's a lot of writing. And I'm sure you guys will want to do the same. So this is, if you have two adjacent angles, does anyone know what adjacent means? Like if I said my room is adjacent to Miss Harrison's room. Nope, it's right here. Next to, because they share the same wall, our rooms are adjacent. Not close by, not like near, share a wall. They are adjacent. My room is adjacent to Miss Park's room because we share that wall. But Miss Park's room is not adjacent to Miss Harrison's room because they're near each other. If you were trying to give directions and someone knew where Miss Park's room was, be like, it's over by there, but not adjacent. My room is adjacent. It means next to, sharing a wall. So two adjacent angles may be added together to make a larger angle. Now that is my version of this. That is not If you Google angle addition postulate, I would be extremely surprised if you get the exact same words. This is, like I've told you a million times, I like to make it as simple as I can, using simple words and simple ideas. So you have two adjacent or touching angles. You can add them together and it'll make a larger angle. The same with the segment addition yesterday. If I had a stick and I broke it into two pieces, those two pieces could be added together to make the length of the stick again. So, the same image just above, right? Just about. If I have A, B, and C, but this time it's not a bisector, it's just another line, call it D. So I could take this purple angle and add it with this blue angle to form the entire big angle, the green angle. And to write that out, I would write angle ABD plus angle DBC equals angle ABC. So I made an equation using that idea. The two little ones can be added together to make the big one. Or, as in this first example, never mind, I almost got ahead of myself. Alright, so that's the idea. So looking at the first example, the measure of ABD is 30 degrees. So I am going to mark that, and as you can tell, I like to use colors. I find it very helpful in geometry. Pictures and colors, so it just simplifies what you're taking in so your brain can process it quicker. So 30 degrees, ABD. Here's A, here's B, here's D. It's that angle. I know it's 30 degrees. Measure ABC is 84 degrees. So ABC, that's the whole angle. That's the big one, ABC. So I'm going to mark it like that. 84 degrees. And that's not a universal marking for the larger angle. That's just the way I like to do it. I feel like it makes the most sense. So that's the way you're going to see me write it. So that's this one. And then it says to find DBC. DBC, that's the one I'm trying to find. So because I know I can add the two little ones together, it's going to equal the larger one. If I already have the larger one, 84, I can subtract the one I know, 30 degrees, and what's left over is going to equal the missing piece, right? So I know that blue one's 54 degrees because 30 plus something has to equal 84. The only way for that to be true is to make it 54. Did I say that right? 30 plus something equals 84. So 84 minus 30 equals that something, and the only way for that to be true is to make it 54 degrees. All right, so that's your basic concept. There's no algebra in there. It's just numbers. But I have to give you algebra. It's what Texas says I have to do. I can't just give you simple problems like that. So we have number 2. The measure of ABD is 2x plus 5. I don't even want to read the rest of it. I know I have identified a part of my figure, so I'm going to mark it. ABD. I have just defined that as my purple section, and here's ABD. 2x plus 5. It's this piece. All right, back to my problem. The measure of angle DBC is 20 degrees. Okay, I'm going to mark it. DBC That's right here. That's 20 degrees. And ABC is 4x minus 35. So the whole thing is 4x minus 35. And since I know, I'm going to add two small angles together and it's going to equal the big one. I can do the purple piece plus the blue piece, and it's going to equal the green piece. Right? Does everyone agree with that? So whenever, as long as I do it like this, it's pretty clear, right? So geometry actually is really easy. It's the fact that you have to throw all this algebra in there. So that is the angle addition postulate. Blue, purple plus blue equals green. All right, but now I need to fill in the values. Since I know I have it laid out right, now I can plug in what I have. 2x plus 5 is purple. So I'm going to put it in there. The blue is 20, so I'm going to put that in there. And the green is 4x minus 35. So now I've created an equation. Now the parentheses were just there for me to see what was happening. They're not actually doing anything to any of these numbers, so it's okay to just drop them because I'm the one that added them. So what do you do whenever you solve an equation? First, you want to combine like terms that are on the same side of the equal sign. So I have a 5 and a 20. So that means I want to put those together. So that's positive 25. And I'm going to bring down the rest of it. 2x equals 4x minus 35. All right, so I combined my like terms on the left. And now I need to get my x's to one side and my non-x's to the other side. You have to it doesn't matter which you go with first. I'm going to move x's first because that's just my habit. And I'm going to take the little one to the big one so that it stays positive. So take baby to mama. 2 is smaller than 4, so I'm going to move 2. If I want to cancel out 2, I need negative 2. And I'm going to do the exact same thing on the other side of the equal sign to that term. So 4x minus 2. Whatever operation you do on the left, you do the same operation on the right. So cancel on the left. 2 minus 2 cancels. That's 0. 25 equals 4 minus 2 is 2, and those are x's, minus 35. I'm almost done solving for x. I need to get my non-x's to the left. So if I have negative 35, I'm going to add 35. Plus 25, that's 60, equals 2x. I ran out of room. So then if I want x by itself, I divide by 2, right? 60 divided by 2 is 30. So x equals 30. However, I was not asked to find x. That's just part of it. What was I asked for? ABC. ABC is green. Find ABC. So that means I need to take this x is 30 and plug it into my green, where there's an x in the green one. Right there. So I'm going to do that right over here. So I have 4x, I'm going to leave a blank, minus 35. The x, I just figured out the x was 30, so that's what I'm going to put in right there. 4x minus 35. 4 times 30. 4 times 3 is 12. There's a 0 there, so that's 120. 120 minus 35. If I do 120 minus 30, that's 90. Take away 5 more, that's 85. So 85 degrees equals angle ABC. Or the measure of angle ABC. Okay, so we did the new geometry concept whenever I stopped with the colored parentheses, and then the rest of it you were just filling in what hopefully you learned in Algebra 1. Okay. And to give you some time to work, I'm going to go ahead and skip example 3 for right, and then I did do it earlier in 4th period, so if you want to see it worked out, it's going to be there in my notes. But I am going to do number 4 real quick, because number 4 doesn't have a diagram, and I want to emphasize that you should draw a picture for every problem pretty much all year long, right? So BD bisects angle ABC. That's a very short sentence, but it tells me what the whole situation looks like, right? BD bisects angle ABC. So angle ABC is what I have. So I'm going to draw an angle, and I'm going to label it A, B in the middle, because the vertex is in the middle, C. And if BD bisects it, that should be ray, a ray BD. Bisect means to cut in half. So from B going up, here's a D, and it's not just in between, but it's actually cutting it to 2 equal pieces. That angle has been bisected. Now I have my picture from that short little sentence. If angle DBC is 20 degrees, okay, pausing myself, angle DBC is 20 degrees. DBC right here is 20 degrees. Find the measure of angle DBA. DBA is what I'm looking for. DBA is right here. So what is it? 20 degrees, right? Because it's bisected. That word, if you didn't pick up on the word bisect, then you wouldn't catch that. But it has to be 20 because they're the same. So angle DBA equals 20 degrees. Okay, and that's where I'm going to stop.